Hi students, this is AJ sir. Let's study 10th standard ICSE Math, Chapter 4A, Linear Inequations, Solving Algebraically. Linear inequations in one variable. Let's start with exercise 4A. Question 1 and 2 are cancelled. Let's start with question 3.1. X belongs to natural numbers. So that's the universal set. That's the limitation on the solution of this inequation. We call it an inequation because there is no equal to sign. This is a less than or equal to sign. So whenever we have a less than or a greater than sign, it is called an inequation. But mostly we solve it just like we solved linear equations, with a couple of extra rules to keep in mind. So we copy this question. Now we have to solve this so that we get x alone. So what do? We transpose 2x to the left hand side, so it becomes minus 2x. And we transpose 3 on the right hand side, so it becomes minus 3. So I got all the x terms together. So that becomes 3x is less than or equal to 15. 3 goes down. Since there is a multiplication, this will become division. So now x is less than or equal to 5. But in the question they have mentioned that x is definitely a natural number. Natural numbers are never decimals, negative or 0. So when they say less than 5, I can't write 4.5 as the answer. I can't go below 1 because natural numbers start from 1. So the solution set is 1, 2, 3, 4, 5. Which satisfies both the condition. It is less than or equal to 5 and also it belongs to a natural number. Next, in the question number 4, cancel Roman number 1 and Roman number 2. Let's do Roman number 3. Let's copy the question. X, we have to find the value of x. The inequation is 8 minus x is greater than 5. So here I'm going to shift minus x to the right, so it will become positive x, and 5 becomes minus 5. So x is less than 5, less than 3. Let me rewrite it as x is less than 3. And the universal set, the limitation in the question is it is a whole number. So whole numbers, they start with 0, but negative numbers are still not allowed and decimals are also not allowed. So the solution set will be 0, 1 and 2. Now there is another way we could have solved this. Just imagine, instead of shifting x on that side, what if we would have shifted 8 on the other side? Then it would have been minus x greater than 5 minus 8. And that's minus x is greater than minus 3. That's fine. And what do we do then? Minus minus cut. But then we are getting x is greater than 3. That's not right. X is less than 3. So that's a special rule in inequations we have to keep in mind. Whenever you are cutting the negative sign on both the sides, the inequality sign flips. Remember this. Don't make a silly mistake. You know what's happening here? When we say cutting negative sign on both the sides, mathematically speaking, we are simply multiplying both the equations, both the sides of the inequation by minus 1. So whenever we multiply a negative number on both the sides, the sign flips. Another case where this could happen is if I say 3 is less than 4, and if I reciprocate these numbers, then I will write 1 upon 3 is greater than 1 upon 4. So again, when you do reciprocal of both the sides, remember this inequality sign flips. So these are the two special rules you need to keep in mind while solving and prevent silly mistakes. Otherwise, the rest of the rules are same. For example, when you are adding something on both the sides, or subtracting something on both the sides, or multiplying and dividing something, then we solve it like we do linear equations. But this rule number 5 and 6 should be studied properly because these are exceptional cases when the signs flip. Also, we should be well aware about the concept of sets. Natural numbers is the smallest set. It has 1, 2 and 3 and so on till infinity. Whole number set includes all the natural numbers plus 0. Then we have integers, which is a bigger set of numbers. It includes all the natural or whole numbers and even the negative numbers -1, -2, -3 till infinity, negative infinity. Then what if we add all the decimal values and decimal numbers or fractions, and decimals can be recurring as well, as you can see here, and yeah, they can be negative or positive. So all these numbers are rational numbers, but there are some numbers whose actual value we don't even know. For example, we don't know the value of pi. It's 3.1415 dot dot dot. Even a supercomputer won't be able to calculate it. In the end, the digits would just keep on appearing till infinity, and you won't even find any recurring pattern in it. It's never ending, so the exact answer is unknown. Same is true for root 3 or cube root of 5. These are all irrational numbers. They cannot be expressed as a fraction. Their exact value cannot be known. We can't plot them accurately on a number line. So together, all these numbers, that is rational and irrational, are called real numbers. Now, there are some numbers which are imaginary, like square root of -1, but we don't have that in our syllabus. Now let's solve 4.5. We copy the inequation. I want the x terms together. So minus x would go here and become plus x, minus 3 upon 2 on the right hand side. No need for LCM, the denominator is same. So 2x is less than 6 upon 2, cut. So x is less than 3 upon 2, bringing this 2 down and cutting. So that x is less than 1.5. And again, the question is that set should have whole numbers. So which whole numbers are less than 1.5? Well, that's 0 and 1 only. Next, let's do the sixth sum. Inequation is given. Roman number 1, well, mark it as an IMP sum entirely. The smallest value of x when x is a real number. Now, that's something new. So we solve this inequation as usual. 16 goes to the left hand side, minus 4x goes to the right hand side. I don't like x to be negative. That's why I shifted minus 4x here to make it positive. Next, after solving, 4 goes down. I get x is greater than or equal to 9 upon 4. That is, it is greater than or equal to 2.25 or 1 upon 4. Now, if I talk about real numbers, so it will include the decimal values also and even fractions. But since it is greater than 1 upon 4, it won't include 0 or all the negative numbers at all. In fact, even 2 won't exist. So if I draw a number line, suppose say 0 is out here. So the number line representation would be like this. Imagine 2.25 to be here between 2 and 3. So from here till infinity, all these values are accepted. All of these will be in the solution set as per this question. And 2.25 is also included, by the way, because there is an equal to sign. Otherwise, I would have had to draw a hollow circle out here. I have darkened the arrow on this side, indicating it goes on till infinity and is a part of the solution set. But they have asked for the smallest value satisfying this condition. That is this one and also this condition. It's a real number. So the smallest number is indeed 2.25. So that's the required value. And in Roman number 2, they've asked us to find the smallest value of x when x is an integer. No need to solve it again. We know that x is greater than or equal to 2.25. So tell me, out of this solution set, which is the smallest integer? Can it be 2? No, 2 is not a part of this. What is the next integer? Integer means no decimal values. So 3 is the smallest integer which will be acceptable. After that, everything is bigger. And here, these values are not even allowed because they are not a part of the solution set. So the answer is 3, the smallest value. Next, let's do question number 7.1. Mark it as IMP. If the replacement set is a set of real numbers, so that's a universal set, and this is the inequation. So let's just copy it. First step. Second step, I want to get rid of the negative sign. So when I cut negative sign, the sign flips. Did you notice that? And then 4 goes down. X is less than or equal to 4. Now, there are so many numbers less than 4. How do I make a list of it? I can't write 3, 2, 1, 0, minus 1, minus 2, minus 3, dot, dot, dot till infinity, because that would exclude all the decimal values. I can't even write 3.9, 3.8, 3.7 because that would include 3.9999, 3.8156, 3.5494 and so on. So there is no way I can write all these infinite values which are agreeable with these conditions. So now we won't write it in the usual form called the roster form. We will write it as a set builder form, and this is true only when x belong to real numbers. So remember, only in such sums do we write the solution set like this, in the set form, set builder form. Solution set is x such that, this colon means such that x is less than or equal to 4. Just copy this inequation here, comma. So that was the first condition. Now the second condition, x belongs to real numbers. See, if in the question they would have mentioned that the replacement set is natural numbers or whole numbers or integers, then we would not have had to write it in the set builder form. We can just list the answer and even put comma, dot, dot, dot to indicate it is till infinity. But when the solution set is a real number, we will have to write it in this method only. There is no other method at all. Now let's have a look at 7.3. Again, the inequation is given. So let's just copy it and solve it further. First of all, get the x terms together. So I will shift this out here. How will I identify whether I should shift this or this in such a sum? Well, I know that this fraction is smaller than this fraction. You see, bigger the denominator, smaller is the fraction. So I would like to shift it here, because then bigger minus smaller will definitely not give me a negative value, and I don't want to deal with negatives as much as possible. So take the LCM out here, into 5, into 5, into 4, into 4. The common denominator becomes 20. So it's 5x minus 4x. And even on the right hand side, we get the value as 4. So the final equation we get is x is greater than 80. But greater than 80, there are so many values. 80.1, 80.11, 80.001, 80.00101, and so on. So how do I even start making a list of these in the solution set? So since the replacement set is real numbers, we will write it in the set builder form instead of listing all the elements. So solution set is x such that x is greater than 80 and x belongs to real numbers. All the conditions have to be mentioned inside curly brackets. Now let's move to the ninth sum. The ninth sum is find the largest value of x, for which this is the inequation and x is a whole number. So once again, copy the inequation, open the brackets and rearrange the terms. So the x's on the left hand side, numbers on the right hand side, and I get x is less than or equal to 3, 2 upon 3. And the replacement set is whole numbers. That means decimal values are not allowed. So which is the largest value of x, which is less than this? Well, definitely it's going to be 3. 4 is not allowed because 4 is greater than this. The largest value of x will be 3 because all other values like 2, 1, 0, minus 1, no, minus 1 won't even be acceptable. This is whole numbers, right? So the other numbers which I mentioned are not the largest value. So this is the answer. If you draw a number line, I can even prove it. So you can see that 3, 2 upon 3 is somewhere between 3 and 4. And it's less than value. So less than will be 3, 2, 1 and 0 also, because it's whole number. That's it. No negative values will be a part of the solution set. And out of these, which is the largest number? 3. So whenever you solve such sums, if you want to draw a number line, you may. Next, the 11th sum. Mark it as IMP. Given that x belongs to integers, and find the solution of this inequation. In fact, I see that it is a combination of two inequations, so we'll have to split it. First, we'll take this part as one inequation out here and solve it, and then we'll take this part, because it has an inequation sign here as well, and solve it separately, so that we will finally get two different inequations in terms of x being alone. On solving this, I'm getting x is greater than or equal to -1, and on solving this, I'm getting x is less than 5. So after having split them and solved them, now we have to combine them again. So how do I do that? It's always x in the center. X is less than something and greater than something. What is x less than? Well, it's not necessary that the one on the right hand side has to be written on the right hand side and this one has to be written on the left hand side. No, it can be interchanged as well. So be careful about that. X is less than 5. So let me just write it here. X is less than 5. And here x is greater than or equal to -1. So I can mention it here. X is indeed greater than or equal to -1. Or simply speaking, I can just draw a number line to show you what it would look like. So this is the solution set on the number line. X is less than 5, so I can't include 5. There's no equal to sign here. I can't even include the decimal values like 4.5 and all, because the universal set is integers and integers don't include decimals. So less than 5 will be 4, 3, 2, 1, 0, -1, -2, -3 and so on till infinity. But there is a second condition here. X is greater than or equal to -1. So I'll have to stop at -1. Yes, I'll include -1 also because there is an equal to sign here, but not here. Remember that. So after having drawn this, so it's so easy to just make a list of it. -1, 0, 1, 2, 3, 4. You have to write it in the correct order, just as it is in the number line. Yeah, if this was belonging to real numbers, then there is no way we could have made a list. We would have written it in the set builder form. Hi students, if you found this video useful, press the like button. Also, to enroll for my online lectures or online test series, email me or message me on Instagram. Check the description for more information.